All right. Good evening, everyone. Thank you for joining us this evening for this informational community session for the Zero Emission Passenger Rail and Trail Project, also called ZEPRT for short. My name is Tiffany Mendoza, and I will be moderating tonight's meeting. We're here tonight to talk to you specifically about bridge infrastructure on the Santa Cruz Branch Rail Line. Before we get into the presentation, I will go over a few Zoom logistics. As a reminder, this meeting is being recorded and will be posted on the project website, along with the recordings of the 3 prior sessions, which are currently available. This meeting is being hosted in English and Spanish. In just a few moments, we will open up the audio translation channels. In order to access the Spanish audio channel, you'll be able to click the interpretation button, which will show as a globe icon in your Zoom taskbar. When you click on that, a menu will appear and you can select your preferred language. At this time, I'm going to pause so this introduction and those instructions can be repeated in Spanish. So I will ask Claudia, our interpreter, to take over.
Thank you. Buenas tardes a todos, bienvenidos. Los servicios de interpretación en español van a estar disponibles de una manera simultánea. Para tener acceso a este servicio, favor de brindar su atención. En la parte inferior de su pantalla en medio van a notar un globo terráqueo o un icono de mundo, ¿ok? Pueden hacer un clic o poner una palomita y se les va a lanzar la opción de elegir ya sea el inglés o el español. Favor de elegir el idioma de español. Y abajo de ello, ustedes pueden ver que en inglés dice mute o mudar. Pueden hacer un clic ahí para no escuchar el idioma de fondo. Y de esa manera ustedes pueden disfrutar de esta junta simultáneamente en español. Ahora, si están teniendo acceso a este servicio por medio de su celular o su tableta o iPad, entonces van a notar 3 puntos a mano derecha de su pantalla, ya sea en la parte superior o inferior. Abajo de ellos, ustedes van a notar una palabra que dice más o more, favor de hacer un clic, y de nuevo se les va a lanzar el globo terráqueo, otro clic, y favor de elegir el idioma de español. Muchas gracias, estamos a sus órdenes. Thank you very much. Back to you.
Thank you. At this time, we will now open that interpretation channel. We invite participants to join the audio channel by clicking that globe icon again. We also suggest that all participants and panelists choose a channel, either English or Spanish. So even if you're listening in English, please click on the interpretation button and select the English channel. That'll make sure you don't miss any audio that may be conveyed from the Spanish interpreters. Closed captioning is also available as well. If you would like to use this option, please click on the CC icon in the Zoom toolbar and then select subtitles to view on screen or live transcript to see the full transcript on the side panel. And if you need technical support during the meeting, please click on the Q&A button and describe your issue there, and our tech support team will help. We've also included the call-in number on this slide, so I'll pause for a moment if you'd like to make a note of how to dial in case you have any internet connectivity issues. Okay, and lastly, for the logistics, our meeting format this evening includes a brief presentation followed by a question and answer session. During tonight's presentation, we will be taking questions in the Q&A box. To ask a question, please press the Q&A button in the meeting taskbar and type in your question. We do encourage you to enter your questions throughout the presentation, and we will address those at the end. For those who are attending in person in the RTC conference room, you can write your questions down on the paper provided and pass them on to the RTC staff in the room, and they will submit your questions via that Q&A box. Okay, and our presentation tonight consists of a project overview, information on railroad bridge infrastructure, and next steps. The presentation will be followed by that question and answer session that I mentioned. And our goal this evening is to try to save the last 30 to 40 minutes to respond to your questions. With that, I will pass the presentation over to Riley Gerbrandt, the RTC's project manager.
Great. Thank you so much, Tiffany. Really appreciate everybody who's attending today. Appreciate that you've taken time out of your evenings to attend today and get information on the railroad bridge infrastructure updates and next steps that we have prepared for you. Thank you to the HDR consultant staff who are helping out with this. Thank you, Tiffany, for that introduction. And for those of you in the presentation, listening to the presentation, it'll be myself doing an introduction, and then we'll have Peter Graff from HDR Bridge Engineer providing information on the technical content of the presentation. Next slide, please. So the first thing we want to do is to provide, for those of you who may be new to the project or haven't followed along through the whole project development so far, a brief project overview of the zero emission passenger rail and trail project. Next slide. As mentioned before, the purpose is going to be to provide those of you who are attending today or listening to this later via recording, an overview of the railroad bridge inspections that have been performed as part of the zero emission passenger rail and trail project, as well as the structures inventory and recommended approach, as well as the bridge replacement type options, as well as the estimated conceptual costs for replacement and rehabilitation of bridges within the project study area. And as Tiffany mentioned, we will have a Q&A session at the end of the presentation for community inputs and feedback. And we do want to encourage people, if you do have questions that you want to ask today, please start putting those into the chat so our team can get those into our tracker in advance, and we can get prepared to answer those questions. Next slide. Now, for those of you who are newer to the project or haven't followed along as closely, the zero emission passenger rail and trail project aims to provide new high capacity passenger rail service and stations on approximately 22 miles of the Santa Cruz Branch rail line from Pajaro Junction in northern Monterey County to City of Santa Cruz. We also included in the project 12 new miles of coastal rail trail, including segments 13 through 20 from Rio Del Mar to Pajaro, as well as the Capitola Trestle Reach, which is segment 11, phase 2. Next slide. And what we've done so far, here's a graphic representing the different milestones that have been developed as part of this project. Back in 2002, the RTC Commission directed staff to take next steps in developing a passenger rail facility along the Santa Cruz Branch rail line. The work that was put together as part of that scope was broken into 4 different milestones, which are shown here on the screen, each including a significant amount of community and stakeholder engagement, with the 4th and final milestone originally scheduled to be concluded in spring of 2025. The first milestone was developing the purpose and needs statement, and milestone 1 was initiated back in February of 2024. Well, the second milestone was producing and getting feedback on the initial conceptual alignments for the passenger rail and trail facilities, as well as the initial analysis of vehicle types. And that began in June of last year. And then the third milestone began in October of last year, commencing with some information sessions, and then went through December of last year and updated the community and stakeholders on the ongoing conceptual alignments, the station locations and features, as well as the ridership approach. A lot of feedback was received by the project team during milestone 3, And in response to that community and stakeholder engagement, late last year, it became apparent that additional engineering and community engagement work was needed in order to gain feedbacks on some of the complex constraints associated with the project's development, including alignment challenges along Walker Street in Watsonville, through the city of Capitola and Aptos, as well as along Beach Street in Santa Cruz. It is crucial for the development of the project concept that the station and alignment options are fully evaluated, because these features affect travel time, ridership forecasts, and project costs. In an effort to provide the community and the project team the additional time to work through some of these challenges and take to the public and get public feedback and engagement, the milestone 4 was pushed back to June of this year and summer 2025 to allow for some additional time for additional information sessions, upcoming workshops, and feedback with project stakeholders and the community. So the initial draft project concept report with preliminary cost estimates is going to be coming out in June of 2025. And we'll have a public hearing scheduled for August of this year, and finalizing the project concept report in the fall of this year. Next slide. And on with that, I'll hand it over to Peter Graff, Senior Project Bridge Engineer with HDR.
All right, thank you, Riley. Yeah, my topic will be covering railroad bridges along the line. As background, most of the existing railroad bridges were originally installed by Southern Pacific Railroad as far back as the early 1900s. In order for us to determine whether these existing railroad bridges are adequate in their current state, we need to look at strengthening and repairs or replacement of each bridge and evaluate those for the following. Number 1 is condition, number 2 is capacity, number 3 is functionality. So this is an ongoing effort, and we're kind of in the thick of it right now. And we've completed the following to date. If you could go to the next slide. So to start off, we have research past bridge records, including as-built drawings, inspection records, and any repair records. We've performed inspections of the existing railroad bridges and performed some select railroad bridge ratings, 4 of which were in the Aptos area. And we have summarized our findings and provided some initial recommendations for each existing railroad bridge based on the inspection and ratings. And then we received general concurrence from RTC late last year. Since then, we've developed a draft conceptual design criteria to use for designing the structures, and we've begun drafting railroad bridge layout drawings. You go to the next slide. So as background on the bridge inspections, we completed those back in February of 2024. We looked at the various span types along the line, which included steel spans, concrete spans, timber bridges, and some steel trusses. The steel spans, we inspected enough information to perform structural ratings if we didn't already have those on file. The concrete spans we visually inspected to assess the condition and ensure there were no immediate structural issues present. Now, the timber bridges and steel trusses, only cursory inspections were performed, as the timber and steel trusses were generally known to be in poor condition ahead of time. So we were confirming those poor conditions as we went out into the field to look at all the structures. Next slide. So now this slide deals with capacity. This is the existing bridge rating results. To start off with, there's a column called as-built Cooper loading. This is, do we have a record of the existing bridge design load within the as-built drawings? And as you can see, there are a few bridges. These are non-timber structures, mind you. There are a few bridges, 5, that have design loading on the as-built drawings that we had. In addition, we have some previous span ratings. A rating is an assessment of capacity from other consulting firms that were completed. And I want to point out that there's it's called previous span rating and normal and max E ratings. Normal is generally assessing the capacity for a frequent load under normal stress conditions. Now, the maximum rating is for a heavy load that comes by every so often, and we have to check to see if the span can hold it. And that's for an infrequent heavy load, and some overstresses are allowed. So that kind of gives you the operating in the upper limit capacity for handling normal and heavy loads on the line. So as a result, we looked at those values and what we had for each bridge, and we saw where are there holes. And we saw, okay, the bridges in the Aptos area, we didn't have ratings for. And there were some other ones down here we didn't have ratings for either. You can see they're indicated on the right. We cannot rate, they're highlighted yellow. But I guess first to start off with these 4 bridges in the Aptos area, we were able to use what as-built drawings we have and the verified field conditions and measurements to develop those structural ratings. So those are the results right there. And then those 4 structures with notes highlighted yellow to the right, those are concrete structures, and we don't have as-builts for them to actually do a rating calculation set. But they are built to railroad standards, and we generally have good records of those old standards, or we do for some of them. So we have a feel for what those should be. They're probably in the E60 to E72 range. These numbers probably don't mean a lot to people. You know, E80 is the current kind of design load for modern design. So that might give you kind of a benchmark of how these compare. But there's a lot more into it, and I won't get into it right now, but that's kind of a summary of our rating results that we have for bridges on the line. Next slide. So with that, we evaluated the existing condition of the bridge and their components. We looked at the span rating capacity, and then now we're investigating functionality of the bridge. So for bridges over roadways, we need to look at, is there adequate vertical and horizontal clearance? If there's a reason to replace the bridge or replace the span, that's when we want to engage the local agencies and see what are your needs to provide improved vertical and horizontal clearances to meet their needs. For bridges that are being replaced over drainages, we want to make sure the hydraulics, what we can convey as flow underneath the spans, is maintained. Next slide. So here's kind of a summary, and it's a lot of information, but here's a summary table of each bridge on the line and what the approach is tentatively selected at this point to be. As you can see, there's a number of bridges with the approach highlighted green and called replace. A lot of the bridges in the beginning of the line are timber, and the timber is generally in poor condition and continues to deteriorate. And timber is more and more difficult to find replacement members for. So it's both the freight industry and commuter line railroads across the country are generally replacing their timber structures because of that difficulty in obtaining material. And then the other bridges that aren't timber, whether they're steel or concrete or trusses, if they're noted for replacement, they're usually, it's because of a low rating or a functionality need that's driving the replacement. Next slide, please. Here's kind of an overview of the project map with the bridge locations identified. The green squares are indicative of bridge locations that are being slated for replacement. And the dark blue circles are where existing bridges will be kept in place with some rehab associated with them. As you can see, for example, in the city of Capitola, there's 5 squares here. That's actually just one bridge, but the way the railroad tracks the condition and capacity of that bridge is by span type. And there's a lot of different span types on that bridge. There's 5 different ones. So that's how they track it, as 5 separate structures in their system. But in the end, it's one bridge over the creek there and over various roadways in Capitola. So just understand that there's not necessarily, there's not 5 bridges here from the when you're seeing it on site. Next slide, please. All right, so starting into conceptual design, as I mentioned, this gets into a little more detail. For bridges over drainages that are being replaced, we want to make sure we maintain the same opening or width. So if we go in with a new bridge, we don't want to put a bunch of extra piers than what's already there. And we also don't want to lower, so that's horizontal width. We also don't want to restrict the vertical height of the bridge too much with a new bridge. So we want to match closely the existing structure depth. Structure depth is just another term for how deep the structure is measured from top of rail to the lowest point on the span, the low chord. Now, for replacing bridges over roadways, yeah, we want to consider vertical clearances. What's there now, and is there a need for improvement? And then looking at horizontal clearance requirements as well, we want to look at, do we need to add bike lanes? Do we need to include sidewalks or increased lane widths? An example we posted here in the photo is Bridge 12.39 over Soquel Drive in Aptos. And you can see these abutments were built just about a foot off of the white fog line of the road. Maybe a little bit more, but it's very close. There's no room for sidewalks or bike lanes. This one, due to low rating and low functionality, is slated for replacement. So we would come in with longer span and put the abutments further back from the roadway, and go with a shallower span so we can increase our vertical clearance. So that's an improvement at that location with the replacement structure. Next slide, please. So our criteria in all this is to design for freight railroad loading. That's indicated as Cooper E80 live load per the ARIMA manual. ARIMA is kind of the design standard that the freight industry uses across the board. The other considerations why we're doing that, designing for freight loading, is the ability to align with the state rail plan and to maintain connectivity with the national freight network. But what that also means is we can, of course, handle passenger trains. And here's some examples on the right of what a diesel freight locomotive looks like, and then a depiction of what a multiple unit passenger train would look like. Next slide, please. So now I'll switch gears and go over what we're considering as tools in our tool belt for replacing these bridges. And we'll go from shortest spans to longest spans. So the first one is a prefabricated concrete span, and there's some photos to the left. These consist of precast, pre-stressed concrete slabbered box beams. There's typically 2 per span. They're ballast deck. Ballast is the rock underneath the ties on the track. These beams are located underneath the track, and they span up to about 45-foot max length. The advantage is that these are one of the most common span types in the freight railroad industry. In fact, freight railroads have entire standards built around them to where the design's already done and for a range of spans, and they just tell a fabricator to order off of those standard span plans very quickly. These are considered redundant span types. They're shallower structure depth. They're fairly simple to replace if damaged. They're relatively low cost, and they're resilient in a coastal environment. A disadvantage is that they're difficult to repair if damaged. Notice that's different than replace. They're easy to replace because they're modular and you can lift them out and they're fairly quick to obtain. But the actual repairs, if you wanted to repair it in place, would be difficult because all the reinforcing steel is internal and it's hard to actually get at the steel and make repairs if that's damaged. And of course, another disadvantage is the relatively short span lengths. Next slide, please. Now, the next span type is a rolled steel beam span, and they're usually made up of rolled steel W-shaped beams, and they're 5 beams per span with a ballast deck. The beams are underneath the track, and they span up to about 69 feet. They're considered a redundant span type with the shallow structure depth. They're simpler to repair if damaged. If you've probably seen it, where a truck may have hit a bridge from underneath and the bottom flange is bent up or maybe even torn. And what you can do is go in there and grind out the tear and splice on plates, bolt on plates to shore up the damage. Or if it's just bent, you can go back and heat straighten it back to the original shape. And of course, this is listed as a advantage of moderate construction cost. That could also be a disadvantage if compared to cheaper construction types. Some of the disadvantages include maintenance and inspection needs are increased over time. There's steel beam spans, they have a lot of connections with bolts and welds and various pieces in between, and those need more attention than a concrete span. These need to be painted every 20 years, particularly if we're on the coast. They have a relative, like I said, moderate construction cost. They have increased corrosion exposure in a coastal environment, and they're relatively short to moderate span lengths. Next slide, please. The next span type is a steel deck plate girder span. These consist of built up welded steel eye girders. There's 4 girders per track with a ballast deck. Girders are underneath the track and they span up to 180 feet. This is a redundant span type and it spans a longer distance than those other spans. I guess I should drop back and state that a redundant span type is one where if a single girder is damaged, there's still multiple other girders underneath there to hold up the span and the track with that one damaged girder. So there's some redundancy. There's extra safety factor included for these redundant type spans. And like the rolled steel beam spans, these are simpler to repair if damaged. Disadvantages are that they have a fairly large structure depth from that top of rail down to the lowest chord of the span. That tends to get deeper the longer you get with your span length. These need increased maintenance and inspection. They need to be painted every 20 years or so. They're relatively moderate to high construction costs, and they are subject to increased corrosion in coastal environments. Next slide. So this next span type is a steel through plate girder. Now these are similar to the deck plate girders in that they're made up of built up welded steel plates, but there's only 2 girders per span and it has a floor system that spans between them. So as you can see in the photo, there's a girder on either side of the track, and then there's a floor system underneath that connects the 2. And what this allows is the top of rail to low chord, that structure depth is reduced so you can provide a shallower structure if needed for clearances. And of course, this span type, you can go up to 180 feet with it. One of the problems with this, or disadvantages, is that it's non-redundant, or what we call fracture critical. If a train were to derail on this bridge, that the girders on either side are susceptible from derailment damage. And it's non-redundant, so if one of the girders is harmed, then it could collapse. So there's an increased risk with this structure type. However, there's also ways to mitigate that risk, and one of them is including inner guardrails on the track to keep a derailed train within the track window. Like the other steel spans, these have increased inspection and maintenance needs. They need to be painted every 20 years or so. They are moderate to high construction cost, and they're subject to more corrosion on the coast. Next slide. The next one is a steel deck truss span, and this is actually, there's one in Capitola. It's similar, not the same as this, but it's similar. This structure type consists of built up steel trusses, 2 per span, with a floor system on top, ballast deck, and the trusses are underneath the track. They span up to 400 feet. These are very long, and they're potentially aesthetically pleasing because people tend to like what trusses look like. These have large structure depths, however, measured from top rail to that low chord. They're considered non-redundant because there's only 2 lines of trusses underneath. However, they're protected by the deck above, so they're not as subject to a derailment damage. They require increased maintenance and inspection, need paint every 20 years. They are relatively high cost and are subject to increased corrosion on the coast. Next slide. So this is the last span type that we're showing. And this span type is actually near the boardwalk area in Santa Cruz. They're steel through truss spans. These consist of built up steel trusses, 2 per span, with a floor system spanning between. On a ballast deck, and trusses are on either side of the track. So this one, we're able to span long distances, but since the track is at the level of the floor down here, we have a fairly low structure depth. And then, of course, there's the aesthetic appeal of trusses as well. The disadvantage is this is non-redundant and fracture critical. And since the trusses are on either side of the track, it's more susceptible to derailment damage. And like the other steel spans, it has increased maintenance and inspection needs paint, is relatively high cost, and is subject to corrosion on the coast. So with that said, those were our tools in our tool belt, and that's what we're considering as possibilities for span types. If you go to the next slide. With that, in all those bridges that were slated or noted as to be replaced, we've developed an initial bridge replacement and rehab cost estimate. These are largely based on past project bid results, examples, and industry experience. We develop a bridge construction cost on a per foot bridge basis first, and then we apply mobilization and a healthy contingency at this level of design. Since this is our first stab at looking at replacement concepts for these bridges, the contingency is set a little bit higher than it would be later on in the design process. And this contingency covers a host of things that are unknowns at this point, whether it's seismic or aesthetics or environmental restrictions, what have you. We also included right-of-way purchases, temporary construction easements, and environmental mitigation as an initial estimate in each bridge estimate, and included professional services and project administration costs as well. And it's noted that this estimate is in current 2025 US dollars only, and there's no escalation included. This is, we don't know when any of these replacements would necessarily occur. So we're we're showing them in current dollars at this point. Next slide. All right, so here is the overview or summary of the railroad bridge replacement and rehab costs. So there's a line item per bridge that was slated or indicated for replacement. And the bottom line, you can see there's a primary span type. These are from the span types that I listed earlier or described earlier. Here's a new bridge approximate length, and here's the cost associated with each location. And our approximate cost is $980 million at this time. Next slide, please. So something that isn't included in these costs, where we don't have non-railroad bridge related infrastructure. So we're not including track work. We're not including any of the trail segments or trail bridge structures. No stations, maintenance, labor facilities, corridor retaining walls, and fencing or grade crossings. We're not including vehicles, alignment shifts, elevated structures at Beach Street. There's 2 bridges over Highway 1 near Aptos that are currently being replaced by a separate project, so they weren't included in this estimate. And there's 1 bridge near La Selva Beach that was previously rehabbed, so is going to stay as is and was not included in this estimate either. And the last item that is listed is environmental mitigations not related to the bridges were not included here. Next slide. So I'll talk about the next steps in our analysis and evaluation of bridges. Next slide, please. So going forward, we're continuing to coordinate with track designers on the conceptual alignment and profile. We're working with a geotechnical engineer on proposed foundation types for these replacement bridges. We are ensuring coordination and meeting vertical and horizontal clearance requirements for new bridges over roadways. We are making sure we match existing hydraulic openings for any new bridges over drainages. And we're in the process of developing a layout drawing for each railroad bridge replacement. When all those things are done, we're going to revisit this conceptual cost estimate for each railroad bridge and rehab and refine for the selected span type, layout, and foundation type that the geotech provides. And then at the very end of all that, we will summarize this, the evaluation and replacement approach in a memo type report and submit for review. With that, I'd like to hand it off to Riley.
Great, thank you, Peter. So a lot of information provided today, and we know that there's quite a few Q questions in the Q&A already popping in. Part of what, as I mentioned in the beginning of the presentation, part of what we're doing here as we step into and look forward to milestone 4 is answering some of the questions and some of the complex engineering issues that came out of the milestone 3 public engagement and stakeholder engagement process. And what we're planning to do as the project team is to answer some of these questions, is to provide a series of information sessions and workshops, as well as presentations to the commission and partners over the next several months. So tonight we had our bridge information session, providing information that the project team has developed on the bridges for the project. On March 20th, we'll be having a presentation to the RTC Commission where we'll present some of this information again, but also some information on funding opportunities, a review of the milestone 3 engagement, and then some of the next steps that the project team is working through in the ongoing work. In April and May, we're having ongoing stakeholder meetings with some of our key stakeholders and partners. as well as focused community meetings and workshops, such as workshops regarding the Santa Cruz Beach Street alignment in front of the boardwalk area, and potentially some others as well. As I mentioned, we also have informational community sessions that we'll be presenting to the community on several other key topics as part of the project development. And then leading into the summer, we'll be providing the draft concept report, presenting that at the beginning of milestone 3, and then wrapping up the project in the fall with the final concept report. Next slide. I believe I hand it back to you, Tiffany, to tell our audience how to participate in the Q&A.
Yes, thanks, Riley. We are moving into the Q&A portion of the meeting. I will note that we've already received a couple dozen questions, so we have a good backlog of questions and responses to get through with you. Before we dig into those, as a reminder, you can continue to enter questions into the Q&A. We know we presented a lot of information here, so as a reminder, you can click on that Q&A icon. There we go. Q&A icon in your Zoom toolbar, or if you're in the RTC conference room, you can write those on the paper provided and provide them to the staff who can enter the questions for you. We will try to read and respond to as many questions as time allows this evening. And I'm going to apologize in advance if the topics of the questions bounce around a little bit, but we will get through as many as we can. So first, I am going to read out what is hopefully an easy clarifying question. So a question was posed by the use of the words capacity and load. Are you referring to weight limits for each bridge?
Great. Peter, why don't you take that one?
Sure. So there's design load or loading, which is what we would call the demand on the structure. It's the applied weight that's placed on the structure. And capacity is the material's ability to withstand that weight. Does that answer the question? Yes.
I think it does.
Okay.
Yep.
Great. Thank you, Peter. All right. The next question I have is, can any of the existing bridge decks or structures be recycled and reused?
Great. And Peter, I'll pitch that one over to you as well.
Yeah, surely they can. It depends on the usage and the demand for them, but and that's not currently our task to investigate, but it is a possibility to reuse those, and there could be some project cost savings accordingly once that's delved into. But yes, they could be reused, especially as potentially trail structures.
Great. Thank you, Peter.
Mm-hmm.
All right. My next question is, what is the design load for passenger rail?
Good question. So I mentioned that freight loading is generally, for new design, it's Cooper E80. And to expand on that a little bit, the 80 represents an 80,000 pound axle, roughly spaced at 5 foot across the bridge for the train, the design train. So for a passenger, typical commuter train would be in the E40s to mid E50s for equivalent Cooper E-load. So it's more than half, but it's just I guess a little bit above half of what a freight train would be. Now, if there's specialty vehicles that are being considered, it could be lighter than that, but it's generally not more than that.
And Peter, I think if I'm looking at some of these questions that are popping in and some of the conversation that we had back in that, I think April timeframe with the commission, there's going from a passenger rail loading, e-loading to a freight e-loading for bridge design. Back in April of 2024, we presented to the commission and people could refer back to that item. But in that presentation, we talked a bit about design, like the increased delta or the increased cost and complexity for designing a new bridge to passenger rail versus to freight rail. Can you provide a little bit of context there?
Sure. So even if you were to lower your design criteria down to a passenger train loading, it's still going to be plus a percentage on top of that. So that I guess to drop back, the E80 is a design load. The actual load from in the freight world that's typically applied is probably in the E65, E70 range. So there's a little bit of fat built in, and that's one of the reasons rail structures last so long is that extra resiliency they build into the design. And so the same thing would have to occur with on the commuter rail side. You would take that, say, E55 and make it E60, 65. But then at that point, you're only, 20%, 25% less than a full freight design load at that point anyways. And the cost savings isn't going to be any more than 10%, because you still have to do all the work. You still have to deconstruct the old bridge and build the new bridge. Yes, you'll save on materials, but materials are only a portion of the cost overall. You still have to do all the work. So yeah, there would be a savings, but I would say it'd be relatively minor when it comes to reducing your design load to say a commuter passenger load.
Great. Thank you, Peter.
All right, the next question asks, can we apply for federal rail money to replace these bridges ASAP, even though the rest of the ZEPRT study is still underway?
Great. Mark, I'll do a preface to this and then kick it over to you to talk about the availability of federal funding for rehabilitation and replacement of bridges. So short answer is yes, there is money to upgrade, rehabilitate, repair bridges for current use. And the RTC has applied for some of those grants in the past. There's federal grants, there's state grants, but they are limited, and a lot of them look at the cost benefit analysis of actually doing the work for the actual service that is currently in place on the line, or the expected increase in service that would be resulting from that work. So Mark, could you explain just in brief a little bit about how maybe the programs that are available and how they operate?
Well, I think most importantly, Riley, and you hit a couple of key points there that I'll reiterate, is that typically the grant programs that are out there do look at a measure of cost benefit in terms of what is being, and they have different measures of what that benefit is, depending on whether it's passenger service or freight service. And it's an economic evaluation that's done. It's kind of getting to the point of what's the return on investment that's being made. But it's also dependent to a large extent on what the service levels are that are being used for a line as well. So if we look at it in the context of the use of this line today, some of those structures might be difficult to justify in some of the grant programs because of the low level of rail use that occurs for the railroad today. And they might rate more highly in a grant program with passenger service being a part of the equation because of the intended use. That's part of the balancing act that goes on between those funds. It's also important to remember, as you mentioned, that there is state money in addition to federal money. Right now, a lot of the emphasis of the state money is to provide the local match to leverage more federal money. So the state money that's available, a lot of it is being aligned with projects that are using that money as a part of an overall program that also draws upon federal money to help maximize the investment that's being made as well.
Great. Thank you, Mark. And I think just to recap that, yes, there are federal and state funds out there, and yes, the RTC is looking at all of those opportunities as they have been released in different funding opportunity solicitations that are released, and where we see opportunity to potentially get some of that grant money or rate well in the rankings to do some rehabilitation or repairs. We apply for those, and like I mentioned before, we did receive one grant to do repairs to the Pajaro River Bridge. But in order to do full replacements and take care of the vast number of bridges we have on our list here, we don't rank very high, and particularly with the current service that we have on the rail line. So the expectation is that probably the best opportunity that we have for addressing some of these issues is with a capital program, such as a zero emission passenger rail or some other capital project. Next slide, Tiffany.
Yeah, thank you, Riley. The next, I'm going to combine two questions here. So I'll read two questions and then let you kick off the response to those, Riley.
Yeah.
So the first question asks, if freight trains are not realistically needed, why are the bridges and trestles being designed or reinforced to support freight loads instead of just lightweight passenger trains? And then related to that, how could cost be removed if we did not require the ability for freight on the rail, specifically south of Aptos?
Great. Well, I think what I'll do is answer the second one first, and then we'll get to the first question with some help from Mark and Peter. So the second question was basically how could we save on some costs by omitting freight from the rail south of Aptos. Currently, the Santa Cruz branch rail line has freight on the whole line, and there is our St. Paul and Pacific Railroad is the common carrier for the Santa Cruz branch rail line, providing freight rail to those who, customers that request it. And as a designation that comes from the Surface Transportation Board of the federal agency, as well as regulations from the FRA. So in order to not design for continued freight on the line, that's a broader question, and kind of one that's been, I acknowledge, is going out and being discussed in the community, but it's not the focus of this project. So this project, when we were directed by the RTC Commission to pursue the project concept development, it was specifically to include freight service on the rail line. And when we went to the commission back in April with a bridge item of last year, the direction from the commission was to design all the new infrastructure as well as the infrastructure repairs for freight loading. Specifically, new bridges and new infrastructure would be designed to a Cooper E80 load. So we're not looking into the nuance of what costs we would be saving by chance if we were to not design for freight. But referring back to Peter's answer, if that was something considered, the difference in cost between bridge infrastructure designed for Cooper E80 versus what a traditional or industry standard is for passenger rail service is on the order of maybe 10%. So it's not a hugely significant amount that we're looking at. So then question one asked if freight trains were not realistically needed, why are the bridges and trestles being designed to support those and not just the lightweight passenger train? I believe I answered that, but Mark, did you have anything to add to that response?
Had to get myself unmuted. No, I think you've clarified that, Riley, and there's a nominal delta between the two, and it's important to remember that the locomotive or the equipment that we're looking at when we talk about multiple units, for example, is equipment that's intended to be interoperable with the railroad main line when it gets to Watsonville. That's what qualifies it in the conversation as intercity service, which makes it eligible for other funding programs that right now are a big emphasis of the administration. And in that conversation, when we look at that, you got to remember that while the multiple unit doesn't look like a freight train, it's still a heavy piece of railroad equipment. And so to the point, the standard for that type of equipment is not much different. And the delta that is there is not a significant savings at this point.
Great. Thanks, Mark. All right, Tiffany, we can turn it back to you for the next one.
Great. The next question asks, are there any types of bridge that could be used in Capitola without removing the existing historic 5 bridges? Could they be left in place underneath, not bearing any load, but just being decorative?
Okay. So the short answer is yes. You with enough money and enough engineering, and deft, you can design things that might be able to do something like this. But realistically speaking, our right of way is very narrow through here. And Peter, I'll kind of tee you up for expanding on that just a little bit. But in order to build a new structure within the existing right of way specifically, and then without extreme changes to the rail profile, which Peter, I think you can talk about, like if we were to build a bridge over the existing bridges, how that would impact the rail profile up and down from the bridges. But that would be extremely cost prohibitive, and then you'd be left with these bridges underneath that are in the current condition that they are, and you need to maintain those bridges and continue to do a high level of maintenance on them just to keep them in the state of kind of existing as they are. But Peter, why don't you talk a little bit about the challenges of doing something like that?
Yeah, sure. So the Capitola trestle, most of that bridge is located on a right-of-way width of 50 feet. So there's very limited room to go either on either side or up or down from there. It's really restricted from a right-of-way width perspective. In fact, this is one location where we're looking at the replacement structure and maybe having to shift the existing railroad alignment within that small right-of-way width to fit both that and the trail structure within that small space. So it's very tight, and and we have the additional challenge of how do we get the trail across that location as well. One thing about that structure is it contains a number, I want to say 15 at least, timber trestle spans that are about 65 feet tall. And all that mass timber is becoming increasingly difficult to source due to all the old growth logging. A lot of it's gone. So it's harder and harder to get that. And as that material rots out over time, because recall it's getting very old, and there's a lot of rot within the stringers and piles, it's just going to become more and more expensive to maintain. Regarding raising the track up and over, that there's limitations on track grade that you can accomplish usually being 1 to 1.5% maximum grades, because trains need a shallow increase in their grade to climb. If you make them steep, they won't work. So in order to go up and over that existing bridge, if that were even possible, the grade extensions on either end of that bridge and retaining wall needs would extend for a long ways. And that would, you know, like Riley mentioned, just simply increase cost in order to accomplish something like that.
Great, thank you, Peter.
Sure.
And I see a lot of, and I want to take just a moment to break and tell everybody that we're continuing to track all the questions, and we do have a lot of questions that have come in the last couple of minutes, and we'll answer as much as we can. And for those that don't get answered, we will, in this live stream, we will put together a Q&A or a FAQ and be able to provide that at a later date. But I do see some questions in here relating to trail and kind of trail specific questions. Tiffany, why don't we pick a couple of the trail questions and answer those?
Yeah, there's a number in here that are related. So I'm going to read a few of them, kind of group them together here, I think.
Okay.
Let me get there. So we ask if there's a few questions. The first is, when considering the adequacy of bridges, are you looking at how to add a trail to each bridge? Related to that one, individuals have also asked, how does having a trail on a given bridge influence the design and cost? And how will rail and trail bridge design be coordinated? So sorry to throw a lot of questions out there at once, but I think those could all be answered together.
Perfect. Yes, we can. And the approach for this project, the zero emission passenger rail and trail project, in the this conceptual design phase, is to have separate trail and rail bridges. The reason for that is the trail bridges are a little bit more flexible with where you can place them. They have different foundation types that we could use. They're much lighter. So where we have the opportunity, we tend to do that from a practicality and also a cost saving perspective. And Peter mentioned like the really narrow right of way in Capitola. When you put two bridges next to each other, it's very challenging to actually fit that in the physical space. And Peter, you can probably, I'll tee you up, but answer the questions and then get to you on maintenance. So, when it comes to maintenance of the bridges, there's when you can separate a pedestrian bridge from a rail bridge, it makes the maintenance on either of those bridges a lot easier in the future. But I think one of the main things is that when we design a structure, and Peter, you can also talk about the Capitola structure a little bit, with a trail and a rail on the same bridge. You're limited with the design options that you have for that scenario. You can put the bridges on the same foundation and have different superstructures, so the actual the bridge part. But if you actually attach the trail to the bridge, it provides unique challenges for construction and for cost too. So for the general purpose at this point, we are pursuing a project concept that has, where possible, separated trail and rail bridges. And so we're coordinating accordingly. So Peter, why don't you talk a little bit about maintenance of the bridges and how that comes into effect, and then what kind of the scenario for Capitola is.
Okay. Yeah, in general, like Riley said, we're keeping trail and rail bridges separate for maintenance reasons. Railroads need to work on, tire replacements and handrail work and surfacing and things that to keep the track level and smooth for, you know, enjoyable passenger rides. So when they go in there and they want to do that typical maintenance, if they have a trail bridge right next to it attached, it just becomes another element that has to be potentially shut down, impacting, you know, public access to that adjacent trail structure so they can do maintenance on the rail structure. So if you keep those separated, a lot of times you don't have to do that. The public can keep going on their trail structure, and the rail side, they can do everything with on-track equipment within their structure limits. So yeah, and on Capitola, the issue there is we're so limited in right of way that we couldn't, if we kept the existing bridge within its width currently, and then tried to add a trail structure next to it, there's not enough room. So we actually have to, that's one of the drivers to replace the existing structure, is we need to move everything over by, I think the center line track shifts by about 8 feet. And in that case, when you shift a bridge 8 feet, there's no way to reuse the existing structure that's there, particularly with the condition it's in. So that one, you're going to have separate superstructures or spans to support the rail and the trail, and they'll probably have a shared substructure and foundation underneath. But we want to keep the spans separate at least, so that, like I said, you don't have to shut one down to do something on the other. And you know, not that this happens, this is not a regular occurrence, but if a derailment happens, you also want your trail structure well away from your rail structure for safety reasons too. That's, you know, obviously uncommon, but it's a good approach to take.
Great, thanks, Peter. Back to you, Tiffany.
Great. I think with those answers, we've kind of jumbled in a couple other questions on trails that had been asked. Riley and I are trying to go through on the back end here and make sure we've addressed the key points to some questions. So even if we haven't read your specific question related to the trail, I think we touched on a lot of them with that answer. I will follow up on one specifically. We may have already addressed this, but one of the questions asks, are these figures only for rail bridges? For example, there was an earlier workshop to provide input on a trail bridge over Aptos Creek. Is that structure and others like it included in these figures? I think that means the cost figures.
Correct. That's what it means. And no, these are just for the rail bridges, so they don't apply to the trail bridges or trail structures.
Okay, thank you, Riley. The next question I have on my list is going to shift us away from the trail conversation. And the question is, can you tell us what the order of magnitude cost estimate means?
Yes. Peter, you ready for that?
Just given the conceptual nature or level of design on this project, the terms used, order of magnitude, we're trying to get a ballpark estimate of where things will hit for the construction cost and the overall project cost. So the term order of magnitude is, are we on the right, you know, are we on the same floor of the building, or are we way off? We're trying to get close, but it's still going to have, you know, here's, instead of providing a single value, we're kind of, it's really about a range. That's what all those contingency percentages were about. We're not going to provide at this point a single cost. It's more going to be an upper limit of that range that we're considering due to the conceptual nature.
Great, thanks, Peter.
Riley, the next question I'm going to pose, because it was asked by a few folks, hopefully will be an easy answer. A few individuals asked if these slides or this presentation will be available for people after this meeting.
And yes, the answer is yes. What we're going to do is take the recording, and we're going to make that available through our RTC website, and we will see if we can make if the PDF of the slides also available.
Great, thank you, Riley. Okay, the next question I will ask is, can you also provide information comparing our project to other comparable projects? Ideally answering the question if it is possible to replace these bridges. And as part of that question, they also asked, is there anything abnormal about this project that would prevent us from replacing the bridges?
Got it. I think what we can do for whoever asked the question, what we'll do for the first part of that question is see if at our March 20th meeting and presentation to the commission, we can give some kind of examples to compare our project with some different projects that have gone before us. With respect to some of the challenges that are specific and some of the things that might be abnormal that make this like a really difficult project, I think I'd just point out that Santa Cruz itself and both our topography and our environmental kind of habitats is a unique aspect to this project, as well as the fact that when it comes to rail, we're off the beaten path. A lot of rail bridge companies might be centered in Stockton, or I'm just guessing here, but maybe in Nebraska, things where there's a lot of rail activity and there's not a significant source of draw for rail related businesses in the Santa Cruz area. So historically, the RTC, when we've done projects on the branch line, find it difficult to entice contractors to bid on our projects, and that's part of the analysis that went into developing the cost estimates and the contingency numbers. That coupled with the challenges unique to Santa Cruz in this topography, with a lot of ravines and crossings and the habitat that we're going to have to go over with some of these bridges. So they make challenges and make it a bit more of a challenging project, but they're not, all bridge projects kind of deal with some of these same challenges, going over waterways and going over sensitive habitat. That's not unique to Santa Cruz, but the magnitude of some of our challenges is different than other places. Back to you, Tiffany.
Okay, thank you. I think we've had a few questions in here related to cost and funding, so let's see if we can get through a few of these. The first one is, would money for the bridge replacements and repairs hopefully come from federal or state government, or both?
Okay. Is there one to combine that with?
Well, I will say yes. I'm going to combine it because you asked. Maybe on a related note,
Yep.
would the train line link with Pajaro Station and Amtrak and Caltrain to Gilroy increase grant advantage for that funding?
Great. So short answer to both those is yes and yes. So with a capital project like this, the largest investors in the United States are the federal government and the state government. The California State Rail Plan lays out California's vision for rail in California, and the the Department of Transportation is investing a lot of money over the next several years in developing the state rail plan. And like Mark said, California is definitely looking for opportunities to maximize state and local investments by leveraging federal dollars. So the strategy definitely is to pursue federal grants for this capital project. And the answer to the train linkages to the UP main line at Pajaro Station or Pajaro Junction is definitely provides a federal advantage for intercity rail, which is one of the programs that we've highlighted as good opportunities for this project. There's the Infrastructure and Jobs Act authorized historic funding for intercity rail in the United States. So targeting that specific program, which would require intercity rail service on the branch line, is a key aspect that the project team has been honing in on.
Okay. Thank you, Riley. I do want to do a time check that we're at 7:15-ish. I will ask one more question and then Riley, hand it back over to you.
Great.
The next question goes back to the trail question and is, if the loading demand were reduced to one exclusively for trail, are there any of the bridges that would need replacement?
Okay. So I'll preface this statement with the zero emission passenger rail and trail project is not looking at removing rail service from the Santa Cruz Branch rail line. So our direction from the commission was to develop a project concept and investigate use of the rail corridor for both rail service and trail service. Now, there are some opportunities for, as Peter mentioned, potentially reusing some of the bridge structures for trail structures. So as we get into detailed design, we will look more at that opportunity. As he did mention, there is limited opportunities for using the existing structures in their current alignment because of the narrow width of our right-of-way. So in order to use some of the structures in their current state, we would need to be able to acquire some additional right-of-way to make that possible for reusing the rail bridges for trail bridges. But in a general sense, yes, some of the bridges would be able to be reused without significant repair or rehab for trail purposes. When you look at that question, we need to look at what is the ongoing operations and maintenance costs of doing that. The timber structures are problematic because, as Peter mentioned, the challenges in getting some of those large mass timber members to do replacement of piles, for instance, are particular issues. So while we aren't investigating that specifically as part of this project, there are opportunities should the commission want to investigate that further. The structures that are most likely reusable would be the concrete structures, for instance. The old steel structures would need some additional analysis because of the corrosion that has happened on those. And the timber structures, it would be while they could be reused, we would need to look at from a operations and maintenance perspective. Is it realistic to reuse some of those structures, given some of the challenges of continuing to maintain and repair them? And so with that, I will wrap up tonight's presentation and information session. I do note, looking at our tracker, that I think we answered less than half of the questions. So we do really appreciate everybody answering or asking questions, and for those that we were able to answer live, we thank you for your questions. For those that we weren't able to get to, we will endeavor to respond to those and make some Q&A or FAQs available in the coming weeks. And with that, I'll sign off for tonight. Thank you, everybody, for coming, and we appreciate you attending. For those who want to stay involved and continue along with the project development. On the screen are 3 different ways that you can get connected and stay involved. We have a mailing list that you can subscribe to at our project website on our secrtc.org/ZEPRT. We also have our project website. That same address links different updates as we continue to develop the project concept. You can also visit our ZEPRT.com webpage, which currently has our milestone 3 open house material still listed there. So if you want to look at some of the older information presented, you can visit that, but you're not able to engage with the feedback portion of that webpage. And then if you have email questions, feel free to email us, and we'll endeavor to respond. And back to you, Tiffany.
And this concludes the meeting. So thank you everybody for participating. We look forward to doing it again in the future.
Thank you all.